Hello everyone, welcome to Talk Mathematics. So today we will be covering the miscellaneous exercise from chapter 1 sets of class 11 NCERT. Now let us start with the examples. So example 28 says show that the set of letters needed to spell cataract and the set of letters needed to spell tract are equal. So let A be the set of elements which consider the letters which are needed to spell cataract. So for cataract we need a letter C, then we need a letter A, then we need T, then we have again A, but you know that in sets we only write the distinct elements, we don't repeat elements. So A is already written, we will not repeat it. Then we need R, and then we need A, C and T, which we have already written. So this is the set A. Now for writing the word tract, we will make a set B. We need the letters T, then R, then A, then C, then again there is T and T we have already written, so we will not repeat it. So set A contains the letters we need to spell cataract and B is the set we need to spell tract. So you can see the elements in A and B are exactly equal. Their number does not matter, where the position where we have written C or A does not matter. So as the elements are same, so we can conclude that A is equal to B. Now next example 29 says that list all the subset of this set. So it is a set which contains -1, 0 and 1. So we have to make a list of all the subsets. So firstly we know that the empty set phi and the whole set this means the whole set A, which is this, is the subset of this. Now further we will break it, like firstly we will make the subsets which contains only one elements, like -1, then we have 0, then we have 1. Now we will start by taking the two elements. We will make a set using -1 and 0, then 0 and 1, then -1 and 1. So in this way, this is the set, means the subsets are 1, 2, 3, 4, 5, 6, 7, 8. So this set has total number of 8 subsets which are listed below. Next example 30 is show that A union B is equal to A intersection B implies that A is equal to B. So this part is given and we need to prove that A is equal to B. So let us begin that. Let us assume that there is an element A which belongs to the set A and then there is an element B which belongs to the set B. So as A belongs to the set A, so A will also be present in A union B, right? Because A union B contains elements of A also and B also. And from here we can say that B element also belongs to A union B, because A union B contains elements of A as well as B. Now from these two equations we can say that A union B is looking like this set, which is A also is present there and B is also present there. So A union B looks like this. Now from the given statement we know that A union B is equal to A intersection B. So we can say that A intersection B also looks like this, which has elements A and B. Now intersection says that it contains the elements which are common in both A and B, means it contains the elements which are present in A also and B also. So the set A contains elements A and B, and then set B also contains elements A and B. We can conclude from this because intersection has elements A and B. Now from this here you can see that A and B has same elements, so we can conclude that it is A is equal to B. Example 31 says that you have to prove that power set, this means power set of A intersection B is equal to the power set of A intersection power set of B. So whenever we have to prove that the two sets are equal, we will begin with the two-step rule which I have stated in the beginning. Step 1 is we will prove that power set of A intersection B is a subset of power set of A intersection power set of B. Firstly I'll prove this, then step 2 I will prove its reverse, that power set of A intersection power set of B is a subset of power set of A intersection B. right? So let us do step 1. So to prove this, we will begin that let there be an element x which belongs to power set of A intersection power set of B. So this means that x is present in both A and B because intersection means the common part. So from this we can say that x is present in power set of A also, and x is present in power set of B also. Now x being an element which is present in the power set of A, so you know that power set is a set which contains all the subsets of the element. So x is a subset of the set A, right? Because power set is what? It is the set of all subsets of A. So if x is an element of power set, that means x is a subset of A. And similarly from here we can say that x is a subset of B. Now x is a subset of A also and x is a subset of B also. So we can say that x is a subset of A intersection B because it is present in both A and B. Now if x is a subset of A and B, that means x element is present in the power set of A intersection B. Now we assume that this was our assumption, that x is present in power set of A intersection power set of B, and this we have proved. So from this you can clearly say that our step 1 property is proved, that power set of A intersection B is a subset of power set of A intersection power set of B. Now we will do step 2. So for step 2 we will assume that x is an element which is present in power set of A intersection B. So power set is a set of all subset, so we can conclude that x is a subset of A intersection B. Now this is the common element. A intersection B has common elements. We can say that x is a subset of A also and x is a subset of B also, because x is a subset of the common A and B. From here we can say that x belongs to the power set of A since x is a subset, and from here we can say that x belongs to the power set of B. Now x belongs to power set of A also and belongs to P also, so we can say that x belongs to power set of A intersection power set of B, because since it is present in both, intersection means only the common part. So this was our assumption and we have proved it. So in this way our step 2 is also proved. Now our step 1 and step 2 is proved. So using step 1 and step 2 we can conclude that power set of A intersection B is equal to power set of A intersection power set of B. So in this way you go for the whenever you have to prove the equal sets. Example 32 says that a market research group conducted a survey of total 1000 consumers and reported that 720 consumers like the product A. So we can write like number of consumers which like the product A is 720. Then we have 450 like the product B. So the number of consumers who like the product B is 450. What is the least number that must have liked both the products? So we have to say both the products means A also and B also. So we need to find A intersection B, because intersection means the common which like A also and B also. So total we have 1000, that means number of elements of A and B including both we have 1000. So you know the formula, that number of elements of A union B is equals to number of elements of A plus number of elements of B minus number of elements of A intersection B. Now this A union B is 1000, A is 720, B is 450, and this you need to find out. So when you will do the sum, you will get the sum will be 1170. You can take here, then you can solve this, and finally you will get that number of elements of A intersection B is 170. Next example is, out of 500 car owners investigated. So in total there were 500 car owners which were investigated. 400 owned the car A. So number of owners who owned the car A is 400. Then 200 owned car B. Then number of owners who owned car B is 200. 50 owned both A and B. Both A and B means the intersection part common, which is 50. And we have in total of 500. That means number of elements of A union B is given as 500. Now we have to check that whether is this the data correct. So we will again write the formula and we'll put it in. Like number of elements of A union B is number of elements of A plus number of elements of B minus number of elements of A intersection B. A union B is given as 500, A is given as 400, B is given as 200, and common elements are 50. So when you will simplify the right hand side, you will get 400 plus 200, 600 minus 50, which is equal to 550. So your right hand side is 550, but your left hand side is 500. So left hand side is not equal to right hand side. It should be equal because this is the universal formula we know, but since they are not equal, so this data is incorrect. Next example 34 is, a college awarded 38 medals in football. So we can write here that number of awards to football is 38. 15 in basketball. So B here is 15. 20 in cricket. C is 20. If these medals went to a total of 58 men, right? So the total is 58. That means football, basketball and cricket all combined is 58. So we will write as F union B union C is 58. And only 3 men got medals in all the 3 sports. So in all the 3 sports means the common which are in common, football, basketball and cricket, which is equal to 3. So how many received medals in exactly 2 of the 3 sports? So we have to find 2 of the 3 sports, means we need to find that number of persons combined only who got football and basketball, number of persons who got basketball and cricket, and number of persons who got football and cricket, right? So we don't need to find the separate numbers, combined we need the number who got in exactly 2 sports. So you know the formula for 3 different elements, that is number of elements of A union B union C. So here we can use the F, B and C. So for A we can write F is equals to number of elements of F plus number of elements of B plus number of elements of C minus number of elements of F intersection B minus number of elements of B intersection C minus number of elements of F intersection C plus number of elements of F intersection C intersection B. So this is the formula. So we need to find this part, right? So we can now put the values. The union value is 58, F is 38, B is 15, C is 20, and we need to find a total of this. So I can consider this as X value plus 3. Now we will calculate the value of X. So when you will add this, so you will get the 76, then X value you will get 76 minus 58, which is equal to 18. So the 18 is the number of all this, of F intersection B plus B intersection C plus F intersection C. So we can see that the number of people, suppose we can write the who liked football plus basketball, then adding it to the number of people who like basketball plus cricket plus football plus cricket is total is equals to 18. So we can simplify it, which means 2 times f plus 2 times b plus 2 times c is equals to 18. Then we will take 2 common, which is f plus b plus c is equals to 18. So finally f plus b plus c is equals to 9. So this is the number of persons who got medals in exactly 2 of the 3 sports. So let us start with first question, which says that decide among the following sets which sets are the subsets of one another. So let us write first of all the A set, which is x belongs to real numbers, which satisfies this equation. So let us do splitting the middle term to find the exact roots of this equation. X square minus 6x minus 2x plus 12. Taking x common, then minus 2 common, we have our factors as x minus 2 and x minus 6, and the values of x to be 2 and 6. So A set is the set of 2 elements 2 and 6. Set B has 3 elements 2, 4 and 6. C has infinite elements like 2, 4, 6, 8 and so on. D has only one element, which is equal to 6. Now the biggest set of all these A, B, C, D is C. So let us begin with the C. The subset of C could be the second largest set, which is B, then A, and then D. So this is the answer for first question. Second question is, in which of the following determine whether the statement is true or false. So if it is true, we need to prove it, and if it is false, we need to give an example. So for first part, let x be an element which is present in A. So x belongs to A, that means A looking like this set x. And we have A belongs to B. A as a whole set belongs to B. So what does B looks like? It looks like it has present A as a whole element, A as a whole set. That means B look like this. X as a set is present here, not as an element. Now it says that x belongs to B, but no, x does not belongs to B. X in the form of a set belongs to B. So the first statement is false. Second statement, it says that A is a subset of B. So let us take an example. Suppose A set has only one element 1, and let B set has two elements 1 and 2. So you know that the B should be the bigger set and A should contained in B. So it clearly here A is a subset of B, because B has two elements and A has only one element. Then we have B belongs to the set C. Now B belongs to the set C, that means C looks like E whole is present here, and there could be many other elements also. Now B has 1 and 2 elements, so B as a 1, 2 is present as a set, and it can also have some other elements as well. Then it says that A belongs to C. So A has only one element, so can you see that 1 does not belongs to C? 1, 2 as a whole set belongs to C, but 1 does not belongs to C. So we cannot say that A belongs to C. The second statement is also false. Third part says that if A is a subset of B. So we can take an example. Suppose A has element only 1 and B has element again 1, 2. So from here it is clear that A is a subset of B, and we have B is a subset of C. So C could be a set like 1, 2, 3. So from here we can also see that B is a subset of C as well. Then can you conclude that A is a subset of C? Yes, clearly from here it is clear that A is a subset of C, because 1 is a subset of the set 1, 2, 3. So the third statement is true. Now fourth statement, it says that A is not a subset of B, so A should not be contained in B. So we take example A as 1 and B as 2. Then we have B is not a subset of C, then B should not be contained in the C set. So C set, let it be like 3. Then A is not a subset of C. So clearly we can say that A is not a subset of C. It is true, coming true from here. But if we take C not as 3, if we take C as 1, then also these two conditions are satisfied, that A is not a subset of B and B is not a subset of C. But here you can clearly say that yes, A is a subset of C. So here this statement becomes false. Now fifth part, it says that if X belongs to A, so A set has an element X present in it, and A is not a subset of B. So A is not a subset of B, so B element will not be containing X, so B would be containing any other element Y and many more other elements as well. Then X belongs to B. No, X cannot belong to B because A is not a subset of B, so the fifth statement is false. Next part is A is a subset of B and X does not belongs to B. So X is not present in the bigger set only. X is not present here. So how can X be present in the smaller set which is contained in B only? So it is always true that X would not belong to A. So the sixth statement is true. Let A and C be the set such that A union B is equals to A union C and A intersection B is equals to A intersection C. We need to show that B is equals to C. So as I told you earlier, we will proceed by two steps. Step 1 will be, we need to prove that B is a subset of C, and then our step 2 will be, we will need to prove that C is a subset of B. So after these two steps we can conclude that B is equals to C. For this proving that B is a subset of C, let us begin that an element X belongs to the set B. Now here the two cases arise. Case 1 would be if X belongs to the set A, and case 2 will be if X does not belongs to the set A. So for first case, if X belongs to B and X also belongs to the set A, we can say that X belongs to A intersection B because it contains the common elements of A and B, and X is in both the sets. Now A intersection B is equals to A intersection C, which is already given. So X also belongs to A intersection C, which is given. Then X is in A also and X is in C also. So the X also belongs to the set C. So we begin with X belongs to B and we are ending with X belongs to C. So from here we can conclude that yes, B is a subset of the set C. For case 2, X does not belongs to the set A and X belongs to the set B. So from here we can say that X belongs to the set A union B because it contains elements of A as well as B. So from here we can say that X also belongs to A union C because here A union B is equals to A union C, which is given. Now here X belongs to A union C but X does not belongs to A, so the only option left is that X must belongs to the set C. So from case 2 also we get our conclusion that B is a subset of the set C. First step is proved. Now step 2, C is a subset of B. We will also approach this similar to this. First of all, let us say that X belongs to the set C. Then again two cases arise. Case 1 is that X belongs to A, and similar we have case 2 as X does not belongs to A. So if X belongs to A and X belongs to C also, then X belongs to A intersection C. It is present in both the cells, so it is also present in the intersection common part, and it is given that A intersection C is equal to A intersection B. So it is equals to A intersection B. Now X is present in both A also and B also, so from here we get X is present in B also. So from here we get C is a subset of B. Now for case 2, X is not present in A, so X will be present in A union C because X is not present in A and in C it is present here, so it will be present in the combination of A and C. Now X will also be present A union B because they both are equal, it is given. Now X belongs to A union B and X is not present in A, so it has to be present in B. because it is present in A union B. So from here also we get C is a subset of B. So from step 2 and step 2, B is a subset of C and C is a subset of B is complete, and using step 1 and 2 we can conclude that B is to C. Fourth question is show that the following 4 conditions are equivalent. So first of all, let us see that 1 implies 2 statement. So first statement says that A is a subset of B. So from here we know that every element of A belongs to B also. So belongs to B also. So they have some common elements because element of A belongs to B also. So if we remove A minus B and it is equal to 5 empty. If we remove the elements of B from A, then we will have nothing because every element of A belongs to B. Now in the reverse we will prove that second implies first statement. Second says that A minus B is equals to 5. So suppose there is an element X which belongs to A, right, and A minus B is 5. So we know that X belongs to B also, because if same element belongs to both the sets, then only it will, when we'll minus it will become 5. So X belongs to A and we are getting X belongs to B also. So from here we will get that A is a subset of B. So second implies 1 is done. Next we will see 1 implies 3. So first statement says that A is a subset of B. So we know that if X belongs to the set A, then X also belongs to the set B. This is the definition of subsets. Now if X belongs to A and X belongs to B also, we can say that X also belongs to A union B, because it has elements of A and B together. So X is present in both A and B, and X is also present in B. So we can say from here that A union B is equal to B. Now we will see third implies 1. It says that A union B is equals to B. So A union B, when we are combining A and B together, they are becoming none other than just the whole set B. So from here it is clear that A is a subset of B. Now we have 1 implies fourth. So first statement say that A is a subset of B, which means if X belongs to A, then X also belongs to B. So X belongs to A also and B also. So X is definitely belongs to their intersection, their common part, and X also belongs to A, we know that. So from here we can get A intersection B is equals to A. Now fourth implies first. It says that A intersection B is equals to A. So when we are taking the common elements of A and B, it is nothing coming but the whole set A. So common elements of A and B and A are equal. So we can get that, suppose we can say that X belongs to A intersection B, X belongs to A also, because they are equal. So if it is present in the common part, it is also present in alone A also and alone B also. So from here we can get that A is a subset of B. So we can say that all these 4 conditions are equivalent. Now for fifth question we have, it is given that A is a subset of B, and we have to prove that C minus B is a subset of C minus A. So we will begin with an element X. Suppose we will assume that X is an element is present in C minus B. And now we will prove that X is also present in C minus A, and in this way we can say that C minus B is a subset of C minus A. So X belongs to C minus A, it means that X belongs to C but X does not belongs to B. Then only we can say X minus B, if we remove the elements of B from C, we will have X. So after removing the elements of B, still we are getting X. That means X is not present in B. Now if X is not present in B and we know that A is a subset of B, it is given. So from here we know that all the elements of A are in B also. So if X is not present in B, X cannot be present in A also, right? So X is present in C but X is not present in A, therefore X is present in C minus A. And in this way we get that C minus B is a subset of C minus A. Now next question 6, assume that power set of A is equal to power set of B, then we need to show that A is equal to B. So this also will prove by two steps. First step, we will say that A is a subset of B, and then step 2, we will prove that B is a subset of A, and using step 1 and 2 we will say that A is equal to B. We assume that X as an element is present in A, right? Now we know that X, when we will make a subset of this set, it will be a subset of A. When we'll make a set, it will be a subset of A. Since it is a subset of A, then X as a subset will be present in the power set of A. Now power set of A is equal to power set of B, so X in a set is equal to power set of B. Now X is present in power set, that means X as a set is a subset of B also. X is a subset of B, so we can say that X is present in B set also. Now from here, we've started with X belongs to A, we are ending with X belongs to B, so we can say that A is a subset of B. Step 2, we will approach this similar way. We will assume that X as an element is present in B, then X as a set is a subset of B. X as a set will be present in power set of B. Power set of B is equal to the power set of A, so X as a set will also be present in power set of A. X set will become the subset of A, and X as an element will belong to A. So from here we get B is a subset of A. So from step 1 and 2 we get that A is equals to B. So 7th question say that it is true that for any sets A and B, power set of A union with the power set of B is equal to the whole power set of A union B. So this statement is false. So for false, we can give a counter example. So consider a very simple example. Let A be the set of only one element is present 1, and B be the set only one element is present 2. Right? Now let us construct the power set of A. The power set of A will be, you know that power set of A, first of all we have an empty set, and then we have the whole set, but there is no other set present in A, so this is only the power set of A. Now similarly the power set of B will look like 5 and 2. Okay, now power set of A union with power set of B, what it will be? It will have 5, 1 and 2. This is the left hand side. Now we will see what is the power set of A union B. For this we need to first construct A union B. So A union B will be elements of A, which is 1, and elements of B also, which is 2. Now the power set of A union B will be, we know that the power set, empty set is always there and the whole set is there, right? Now 1 and 2 is also present, so we will have the single elements 1 and 2 also in the power set of A union B. So you can see that power set of A union with power set of B has only 3 elements, 5, 1 and 2, but power set of A union B combined has 4 elements. So therefore they are not equal and the statement is false. Next we have 8th question, which says that show that for any sets A and B, if A is equal to this and A union B minus A is equals to this. So we can divide it. First part we will perform here. So for first part we will have two approaches, that only step 1 will be, we will prove that A is a subset of A intersection B union A minus B. Then in step 2 we will prove that A intersection B union with A minus B is a subset of A. So for step 1, let us say that X belongs to A. Now we have two cases arise. Case 1 will be X does not belongs to B, and case 2 will be X belongs to B. So if X belongs to B and X belongs to A also, then we can say that X belongs to A intersection B, right? from case 1, if x does not belongs to b and x belongs to a, then we can say that x belongs to a minus b. Means if we are removing the b element from a, then x is present in a. So from these two we can say that x as an element is present in either a minus b, or it will be present in a intersection b. So combinedly we can say that x will be confirmedly present in a minus b union with a intersection b. Right, so from this step we get a is a subset of a intersection b union a minus b. Step 2, we will begin with that x belongs to a intersection b union with a minus b. Right, now x is present in union, so either x will be present in a intersection b or x will be present in a minus b. So if x is present in a intersection b, that is confirmed that x will be present in a. Now x is present in a minus b, so this from here also it is confirmed that x is present in a. So we can clearly get that a intersection b union with a minus b is a subset of a. So from step 1 and 2 we can conclude this first statement, that these two sets are equal. Now for the second statement, here also our step 1 will be a union b minus a is a subset of a union b. Then our step 2 will be a union b is a subset of a union b minus a. Now for this statement we will begin with x belongs to a union b minus a. So from here we will get that either x belongs to a or x belongs to b minus a. Right, from here x belongs to a, x belongs to b minus a, this means that x confirms belongs to b. So we are getting that x belongs to a, x belongs to b. Now we can say that from here that x belongs to a union b, and from here we will get that a union b minus a is a subset of a union b. Now for step 2 we will begin that x belongs to a union b. So from here we can say that either x belongs to a or x belongs to b, or it may belongs to both. So if x belongs to a and x belongs to b, from here we can say that x also belongs to b minus a. If we remove a from b, then we will left with x belongs to b. Here is or statement, not and statement. So from here we have x belongs to a, and here we have x belongs to b minus a. So when we combine this we can say that a union b is a subset of a union b minus a. So from these two steps we can conclude the second statement as well, that these two sets are equal. Second statement is proved here, first is here. Now for ninth question, using properties of sets we need to prove these two things. So for here we will prove the first part, and here we will prove the second part. So the approach will be same. Again we will have to give two steps here, the step 1 and step 2. So step 1 will be, we need to prove that a union a intersection b is a subset of a, and for step 2 we will prove that a is a subset of a union a intersection b. For step 1, let x belongs to a union a intersection b. Right, now either x will be present in a or x will be present in a intersection b. So if x is present in a, our job is done. So if x is present in a intersection b, then we can say that x is present in a because it is present in the common part. So from here we can clearly prove the first step. Now for step 2, let x belongs to a. So if x belongs to a, we have two options, either x will belong to b or x will not belongs to b. So if x belongs to b, then x also belongs to a intersection b, and x is present in a also, then our job is done, which is a is a subset of a. So these are the two cases that has arrived, case 1 and this is the case 2. So if x is not present in b and x is present in a, then x is only present in a, it cannot be present in a intersection b. So x is not present in a intersection b, but we know that X is present in A. So we can say that X is also present in A union A intersection B, because union contains both the elements. Okay, so X is present in A also we get from here. So step 2 also this statement is proved. Using step 1 and step 2 we have arrived at a solution that A union A intersection B is equal to the set A. Okay, now for second part also we will go with step 1 and step 2. Step 1 is to that A intersection A union B is a subset of A. In step 2 we need to prove that A is a subset of A intersection A union B. Now we will begin that X belongs to A intersection A union B intersection, that is X is present in A also, and since there is intersection X is present in A union B also. So if X is present in A, the job is done. Now it says that X is present in A union B. So okay, X is present in A union B, it says that X is present in either A or B. So since there is an AND statement, we have only one statement done, and we can prove this subset thing, that A intersection A union B is a subset of A. Now for step 2, let X belongs to A. Now we have either X belongs to B or X does not belongs to B. So if X belongs to B, then X belongs to A union B also we can say, and X also belongs to A intersection B. So this subset property is proved. So if X does not belongs to B and X is present in A, we can say that X is present in A union B also. From here also X is present in A but not in B, but in A union B X will be present. Now X is present in A union B also and X is present in A also. We can say that X will also be present in A intersection A union B. So from step 1 and step 2 we can prove the property that A intersection A union B is equals to A. Now for 10th question we need to show that if A intersection B is equal to A intersection C, this statement does not imply that B is equal to C. So this statement is false. So whenever the statements are false, we need to go by counter example. So we will take a very easy example. Let A be the set containing only one element, B be the set containing 1 and 2, and C be the set containing 1 and 3. So we can clearly say that A intersection B is what? The common elements in A and B is 1, and A intersection C, common elements of 1 A and C is also 1. So they A intersection B and B intersection C are equal. So the given part we have taken correctly. Now this need not imply that B is equal to C. So clearly you can say that B has element 1 and 2, C has element 1 and 3. So B and C are not equal. Now for 11th question, let A and B be two sets and these two properties are given. We need to show that A is equals to B. So whenever we need to show that two sets are equal, we have to start with two steps. Like A is a subset of B, we will prove this in step 1. Then in step 2 we will prove that B is a subset of A. Now for A being the subset of B, first of all let us begin with that X as an element belongs to A, right? Now using the hints, first hint is A is equals to A intersection A union X, right? Now A union X is equals to B union X, which is given. So A is further equal to A intersection B union X, given. Now the property of intersection will open this property. A will be equal to A intersection B union A intersection X. Now A intersection X is equals to phi, which is given. This is equals to phi empty. So A is equals to A intersection B. So now the common parts of A and B are making together the whole set A. So from this we can conclude that A is a subset of B. This is the one of the property which we proved previously also. Now using the second hint that B is equals to B intersection B union X, right? Now B union X is given that it is equal to A union X. Now we will open the property which is equal to B intersection A union B intersection X. B intersection is X given to be phi, so B is equals to B intersection A. So now here we have the common elements of B and A is making the whole set B. So from clearly we can say that B is a subset of A. So the two properties, the two steps say that from step 1 and step 2 we can say that A is equals to B. So these two hints which are given, you can also memorize these two hints using the Venn law. So we can say that from here if you make two sets, for I am explaining the hint number 1. Hint number 1, it says let us consider two sets A and X. So he is saying that A and with the common elements of A union X. So if this is A set and this is X set, it says that A union X. A union X is whole this part. Its common elements with the A. This part the common element with A. Now let us shade the A region. So A region is this. So what is the common part in red and blue color? It is the whole set A. So you can verify this hint by using the Venn's law as well. Next we have 12th question which says that find sets A, B and C such that A intersection B, B intersection C and A intersection C are non-empty and the sets A, B, C intersection is empty. Let us see A set which contains 1 and 2 elements, B set which contains 2 and 3 elements and C set which contains 1 and 3 elements. So you can see that A intersection B has common element 2 which is non-empty, B intersection C has common element 3 which is non-empty and A intersection C has common element 1 which then it is non-empty. So now the sets A intersection B intersection C. So we need to find an element which is present in both A, B and C. So it is no such element which is present in all the three, so this is 5. So this is one such example. Next up is 13th question which says that in a survey of 600 students, so total the students were 600, 150 students were found to be taking tea. So we can write that number of students found to be taking tea is 150. 225 taking coffee, so number of students taking coffee is 225 and 100 were taking both tea and coffee. So both tea and coffee means the common part, so T intersection C will be 100. And now in total there were 600 students. So let us find out how many of them were taking either tea or coffee. So we know the formula, it will be number of elements in T plus number of elements in C minus number of elements in T intersection C. So it will be 150 plus 225 minus 100. So its answer you can calculate, it will come after calculation 275. So we know that number of elements of T union C is coming out to be 275. You can understand this using the Venn diagram. Suppose this is the students taking tea, this is the students taking coffee, right? So we need to calculate neither tea nor coffee. So we need to calculate this shaded region, right? So how can shaded region be achieved? It can, the total is 600. So it can be achieved using total minus number of elements of T union C. So it will be 600 minus 275. So the answer will be 325. So 325 are the students which take neither tea nor coffee. Next up, 14th question we have, in a group of students, 100 students knew Hindi. So number of students who knew Hindi are 100. 50 knew English, number of students English is 50. 25 know both, so both the languages, so it will be Hindi intersection English, it is 25. Each of the student knows either Hindi or English, so it is no such case that nobody knows any of the two languages. Now how many students are there in the group? So total number of students we need to find H union E. So we will proceed by formula. H union E is number of elements in H plus number of elements in E minus number of elements in H intersection E. So it will be 100 plus 50 minus 25, which is 125. So next up we have 15th questions, which says that in a survey of 60 people, it was found that 25 people read newspaper H. So number of people who read H is 20. 26 read T newspaper, then 26 again read I newspaper, then we have 9 read both H and I. So H intersection I is 9. 11 read both H and T, so H and T intersection is 11. And 8 read both T and I, so T and I intersection is 8. 3 read all the 3 newspapers, so number of elements in H intersection T intersection I is equals to 3. So for first part, we need to find the number of people who read at least one of the newspaper. So at least one of the newspaper, that means we need to find H union T union I. So by the formula we know that it is equal to number of elements in H plus number of elements in T plus number of elements in I minus number of elements in H intersection I minus number of elements in H intersection T minus number of elements in T intersection I plus number of elements in H intersection T intersection I. So one by one we will fill out the values, which is 25 plus 26 plus 26 minus 9 minus 11 minus 8 and plus 3. So after calculation you will get this as answer as 52. Now the second part, it says that the number of people who read exactly one newspaper. So exactly one means first of all we need to find the people who read only the newspaper H. For this we will write only the terms that contains H from this formula, which is number of elements of H minus number of elements of H intersection I, then number of elements of H intersection T, then plus number of elements of H intersection T intersection I. So we have written only those terms which have I in them from this formula. Now we'll put the values as 25 minus 11 minus 9 plus 3, which is equals to 8. So this is the answer for number of people who read only one newspaper H. Similarly, now we need to write only T newspaper. So we will write the terms which contains T in them. Number of elements of T minus number of elements of H intersection T minus number of elements of T intersection I plus number of elements of H intersection T intersection I. So putting the values, 26 minus 11 minus 8 plus 3 gives 10. Only I is equals to number of elements in I minus number of elements in I intersection H minus number of elements in T intersection I plus number of elements of H intersection T intersection I. Putting the values, we get 26 minus 9 minus 8 plus 3, which gives a total of 12. The 16th question is, in a survey it was found that 21 people liked product A. So number of elements in A is 21. 26 like the product B. So number of elements in B is 26 and C is liked by 29. If 14 people like products A and B, so A intersection B is 14. 12 people like products C and A, so C intersection A is 12. 14 people liked B and C, so B intersection C is 14. 8 liked all the 3 products, so number of elements in A intersection B intersection C is 8. We need to find how many liked product C only. So product C only, as we have done in the previous question, it will be given by number of elements in C minus number of elements in C minus C intersection A minus number of elements in B intersection C plus number of elements in A intersection B intersection C. Putting the values, we get 29 minus 12 minus 14 plus 8, which gives the answer as 11. So that's all for the miscellaneous exercise of chapter 1 sets. So you can, in the playlist you can find out full NCERT solution of each and every exercise. Now in the next playlist we will be covering the next chapters of class 11.